Hi friends, I am Sujoy and I welcomes you to my new series of video where I am telling you how to find out the LU decomposition of a matrix. This is my first video in the series and today I will tell you how to find out LU decomposition by shortcut method. In my next video I will show you that L and U are not unique to a matrix. There may be more than one L and more than one U for a matrix. Also in my upcoming videos I will show you that there may not be LU decomposition for some matrices and some rules regarding the decomposition. So for now let's start with the shortcut method. So before we start the calculation part, that is this part, let me tell you some basics. If you don't want to know the basics, you can forward the video and directly go to the calculation part, but I will insist that you follow the theory part, that will strengthen your concepts. So let's start the theory part. This is a square matrix A where number of rows and number of columns both are 3. That is, it's a 3 cross 3 square matrix. Next, this is called row 1 or R1, this is R2 and this is R3. Similarly, this is called column 1 or C1, this is C2 and this is C3. And this is called the diagonal. And the elements 1, 15 and 26 are called the diagonal elements. And each element in a matrix has a coordinate to represent it. For example, the element 1 has a coordinate of A11, that is first row, first column. Similarly, let's say for this element the coordinate is A23, that is 2 for second row and 3 for third column. And these are square matrix where number of rows and number of columns both are equal, that is 3. Next we will break down or decompose the matrix A into two submatrices, L and U, where L is the lower triangular matrix. Lower triangular means all the diagonal elements are 1 and values above the diagonal elements are 0, and we have elements or real values only below the diagonal elements, that is lower to the diagonal elements. That's why it's called lower triangular matrix, because it forms a lower triangle. And next submatrix is U, that is upper triangular matrix, where we have values only in upper part of the diagonal, including on the diagonal elements, and the values below the diagonals are all 0. So U represents the upper triangular matrix, where the upper part forms a triangle. So just remember, U is upper and L is lower. So here is a small note for you. Note 1. L and U denote lower triangular matrix and upper triangular matrix respectively. The format of L and U is given above. Note 2. Matrix A must be a square matrix and must be able to reduce to row echelon form U without interchanging the rows. Here U is called the row echelon form. Row echelon means we have values on the diagonal elements and above the diagonal elements, and all the elements below diagonal are 0. This form or representation of a matrix is called the row echelon form. Note 3. L and U are not unique. There may be more than one L and more than one U for a matrix, which I will demonstrate in my next video. So don't forget to watch my next video. Note number 4. Using the opposites of the multiplies used in row operations, we can build L, which I will demonstrate in this video. Note 5. An invertible matrix has LU decomposition only if all its leading submatrices have non-zero determinants. Note 6. A is equals to L into U, but the opposite is not true. That is, A is not equals to U into L. So this was the basic. Let's start the calculation. So this is our original matrix A, rewritten once again. So our objective is to get 3 zeros, one at this position, one at this position and one at this position, as shown in U. That is, we have to reduce it to row echelon form. So first we will get a 0 at this position. For that we can multiply the row 1 by 3 and subtract that from row 2. So we have written that here R2 is equals to R2 minus 3 into R1. So let's do it. 3 minus 3 into 1, that's equals to 0 at this position. And next 15 minus 3 into 3, that's equals to 16 minus 9, 6. And similarly 20 minus 3 into 4, that's equals to 20 minus 12, 8. So we have got a 0 at this position. Next we will get a 0 at this position. For that, again we can do multiply the row 1 by 2 and subtract that from row 3. So that we have written here, R3 is equals to R3 minus 2 into R1. So let's do it. 2 minus 2 into 1. So that's equals to 0 at this position. And 18 minus 2 into 3. That is 18 minus 6. That is 12. And 26 minus 2 into 4. That is 26 minus 8, 18. So by that we have got a 0 at this position. Next, according to the row echelon form, we have to get 0 at this position. So for that we can multiply the row 2 by 2 and subtract that from row 3. Remember, we will not use the row 1 in this case, because if we do so, this 1 will be multiplied by 2 and we will get a minus 2 at this position. So this 0 will vanish. So we have to use the row 2 only, since the row 2 has a 0 at this position. So R3 is equals to R3 minus 2 into R2. So that's equals to 12 minus 2 into 6, that's equals to 0, and 18 minus 2 into 8. So 18 minus 16, that's equals to plus 2. So we have successfully converted matrix A into a row echelon form, and this is our required U. And now we find out the L. L is given by note number 4. Using the opposites of multipliers used in row operations, we can build L. So let's review it. To get a 0 at this position, we have multiplied R1 by minus 3. So we'll use the opposite value, that is plus 3 at this position in L. Similarly, to get a 0 at this position, we multiplied R1 by minus 2. Similarly, we'll use the opposite value plus 2 at this position in L. And finally, to get a 0 at this position, we multiplied the R2 by minus 2. So we'll use the opposite value plus 2 at this particular position in L. And remaining format, that is all diagonal elements are 1 and the values above diagonal elements are 0, we obtain from the standard form of L. So the summary is, the process is very simple. First we have to apply the row operations on matrix A to reduce the matrix A into a row echelon form with lower triangular values as 0. And next we will just find out the opposite of the values which we used in row operations to find out the corresponding elements, and we will use the opposite of those corresponding values and we will place them accordingly on our matrix L. So we have obtained the LU decomposition of matrix A. So if you multiply the L and U, you will get the original matrix A. So that's it for now. How was the video? Let me know in the comments below. I will upload more videos on LU decomposition. So don't forget to subscribe to the YouTube channel so that when I upload my next video, you will get an email if you subscribe. So thanks for watching. See you in my next video, and till then stay connected by subscribing.